Hello everyone. In this video, I'm going to show you a software that I created to control my 3D printed robotic arm. Well, as you know, to control a robotic arm, we need to perform various calculations like forward and inverse kinematics calculations. And to input those various parameters and to having setting multiple angles and all. So I created this software which will take input from the user like the angles in forward kinematics and the uh, end effector position in inverse kinematics, and then calculate it and take out necessary information and then send it to a microcontroller to control my robotic arm. So coming back to the software, I created this software, I structured this software in multiple tabs, each tab performing different tasks. Like first tab, the serial interface. Actually, it initially used to have only serial interface. Now I have added the Wi-Fi communication as well to function well with my ESP32. So I have programmed my ESP32 to connect to my home Wi-Fi router, and I have set it to a specific IP address, that is 192.168.31.210, and port is 5000. So when I click on connect Wi-Fi, as you can see, the Wi-Fi is connected. It's showing here in green. When the microcontroller is connected, it sends a message to this software to my computer that the software is ready. Now coming back to the next tab, robot parameters tab. This tab actually takes in the DH parameters of the robot. Hence, this tab is very crucial to get the data about the physical information about the robot that we intend to control. I've used JSON here to import and export. That is basically load and save the entire table so that I don't have to write each value multiple times again and again whenever I open the software or like reload it. Anyways, let me just quickly wait, let me show you. When I have not saved any parameters or when I have not loaded any parameters, as you can see the forward kinematics tab here, we have the joint controls and positions, XYZ coordinates. Here on the left hand side I have some preset buttons, and here I have made a motion sequence recorder so that I can record certain steps of the robot and then play it in sequence in loop that usually generally robot do some repeated task. And in inverse kinematics, as you can see, the same. Still we don't have any robot on the screen. Here we have on right hand side we have XYZ position coordinates for the end effector, and then we have compute inverse kinematics and angles, and on the left hand side again some preset buttons and then motion sequence. Anyways, now coming back to robot parameters, let me just quickly load well, yeah, this I think I have created a trial version for just for example. Let me just open it. As you can see, values are now loaded, and certain values now I have to enter, like type of robot, it's 3 degrees of freedom, joint is 0 to 180, minimum maximum angles I'm just defining because I'm using MG 90, I think it's 90 MG, yeah, MG 90 servo, which usually have a range of motion to 180 degrees, from 0 to 180 degrees. Yeah. So after setting, since I have only 3 degrees of freedom, I don't need to set others. And home position, let me just put it to, well, let's just put it to 90 midpoint. Then I think this is around 60 and this must be around 45. Yeah. So after setting this, let me just save the parameters. Yeah. When I save the parameters, as you can see, I have created a console log on the bottom of the screen, which generally shows what's happening in the background. Like initially, when I connected or disconnected to Wi-Fi, it's giving a success or information message. And then when I imported the parameters using the import dh JSON, this line shows that from where it was imported and which file was imported. Then when I set the degrees of freedom to 3 and DH table and everything, it says the robot parameters is updated. So it basically shows what's happening in the background in the software, all the necessary information. Anyways, so once I have saved the parameters, as you can see now, in the forward kinematics and inverse kinematics, a line diagram of the robot has appeared. This has the exact dimensions of the robot that we have set, as you can see from the XY plane. I have given this feature to view the robot from multiple planes. I was getting a call now. Anyways, so where was I? Yes. As you can see, this we can view this from multiple angles, multiple. So as you can see, we can view the robot from multiple perspective, like from the XY plane, YZ plane. Anyways, and there is this reset button which resets it to orthogonal view. So what I was about to show you, that as you can see, as per the robot parameters, I have set the link length to 100 mm each, and you can see it is exactly 100 mm. So basically, this is the exact representation of the uh, robotic arm just in the line diagram format. Now, in forward kinematics, when we enter the angles, oh wait, the sliders are not reset. It's still showing minimum as 90° and maximum as 90°. But when I reset slider limits, and now you can see it's from 0 to 180, 0 to 180. So now all the three sliders that I have set the values are now reset, except the sliders which I have not set the values for. As you can see, in joint 4, 5 and 6 I have not set the values, so it's still showing from -90 to +90. Anyways, let me just reset it. Home position. Yeah. So as you can see, when I click on home button, it attains its home position, that is 90 degrees, 60 degrees and 45 degrees each. This is the home position. And when I jog down the slider, it moves the robotic arm in the simulation here. Now once I see that okay, this position is what I want my robot to achieve, this is the XYZ value of P3, that is this black dot is the P3, this point is P2 and this point is P1, and hence when I see that P3 is the desired position that I want, if I click on send to microcontroller, these angles are sent to microcontroller, and in serial interface you can see that the microcontroller received the angles and sent a acknowledge message back to the computer through Wi-Fi. So this means that the robotic arm software acknowledged that it received the angles that has been sent through the computer, and then it acknowledges and sends back what it has acknowledged, this thus confirming that the microcontroller has successfully received. And this actually was very useful in debugging, like whenever I used to send angles to the microcontroller and robot didn't move, so at least I was sure that at least microcontroller is receiving the angles. It's not that it's not receiving the angles, it's receiving, but there might be some other problem. So it helped in figuring out other problems that might lie in my software. Anyways, coming back to forward kinematics, when I move the slider, the robot moves. Similarly, in inverse kinematics, we have this XYZ position text holders. Like when I input, let's say 150 in X direction in 150, let's say in Y direction, I want 30 mm up from 0 to 30. I think it would be something around this. And in Z, let's say, wait a minute. In Z, let's say it's also 30. Let's say when I click on compute, you can see that there is this yellow cross over here. Wait, let me just, yeah. You can see that there is a yellow cross which shows the entered position. This is the desired position that I wanted to achieve, and the black dot, as you can see, the black dot here, which shows the exact position of the end effector. And hence, since these two are coinciding right here, that means the inverse kinematics after calculating has achieved the exact position that I wanted to achieve. And using these angles, you can see here current joint angles, you can see J1, J2, J3, which are 98, 47 and 41 degrees. But since we know that in inverse kinematics, we generally get two solutions or one solution or no solutions at all. In this case, we are getting two solutions, elbow up and elbow down. This solution that is being displayed right now is the elbow up position. And when we select the elbow down position, the angles change and the elbow down position is achieved. Hence, we can see which position fits our robot, and we can select it accordingly. After selecting it, after verifying the angles, we can click on apply solution and send to microcontroller, and these angles will be sent to microcontroller. And hence again, if you see that it has acknowledged it. So right now, till now, I have shown you how my inverse and forward kinematics works. Here also I have a home, page, some preset buttons. Well, there is one more feature that I've added. Like, let's say I have this home position as 200 in X, in Y, let's say it's 0, and in Z, let's say it's 60. Compute it. See, since this position can only achieve in one possible way, you can see there is only one solution here. So this one position, let's say it's my home position. Now here you can see that home is currently 0, 0 and 150. When I click this, it achieves this position, or in elbow down it achieves this position, which I don't think this should be my home position. As per my robot's geometry, I don't think this will be my resting position. So let me enter my resting position that I think that I want my robot to have. So let's say this is my home position for my robot, and when I click on set, and let's just rename it. I mean, I can or I cannot rename it. It's just a feature here. Well, yeah, as you can see, home one, and it has reset to 200, 0 and 60. So now let's say it has achieved this position, and now I want to achieve my home position. When I click it, it will go to my home position. This is a new feature that I was thinking of and then added it to my software. Initially, I had features like this, like simple button always uh, preset to home positions from this tab. But then I thought of this idea and then implemented it in inverse kinematics. Similarly, I can modify pick, place, and other buttons as well. I can rename and modify the angles. Now let me show you the motion sequence part. Uh, each time, let's say I'm inputting an angle, let's say 150, Z60, compute, yeah, elbow down. Well, my robot is actually in elbow down position, so each time I'm using this. Anyways, so let me compute it and then apply. Once it's applied, I can record this step. As you can see, step number 0 and inverse kinematics, this IK means inverse kinematics. From inverse kinematics we are getting this. Actually this is something that is common in both forward and inverse kinematics. For example, let's say if I'm recording here, record step, you can see both these steps are now displayed here. When I will show you my background code, you will see that there is only one file that handles the whole motion sequence for both the tabs. It basically gets the angles and the positions and then just stores it. So it just marks it as inverse kinematics or forward kinematics, and hence it can be distinguished that which exact tab has given this angle. So from inverse kinematics I've got these angles, and from forward kinematics I've got these angles. And then there is this delay between each step. There will be a delay of 500 millisecond. Actually, I have this text box here in which I can enter the amount of time that I want in between each step. And then loop sequence is something that we will use while playing the uh, motion sequence. Anyways, coming back to inverse kinematics, or let's say I'll show you in this forward kinematics as well. Well, let's say this is the angle first I want to achieve, record it. Then let's say I want to achieve this angle, record it. Then let's say this angle, record it. Then this position, record it. If I want to delete the last step, which is let's say was a mistake, then I can click on this one, or I can clear this whole thing clicking on this button. And if I want to see all the steps that I have done, I'll play the sequence now. Clicking on play sequence, it will play it. And since I have not selected the loop sequence, it just played once. It will just play it once. All the 5 steps, playing it once. So as you can see, if I click on play sequence, it plays it only once, all the 5 steps. Now when I click on loop sequence and play it, it will keep playing in the loop. Again, looping sequence started again. So when I click on stop, it will stop. So yeah, this is my whole software that I have created to control my robotic arm. It can go till 6 degrees of freedom as well. Let's say, let me show you something else then. Well, let's just enter 10, actually not 10, 50 should be visible. 50, 50, 50 and 90, 90. Save. Let's say this is my DH parameter for 6 degrees of freedom robot. And when I click on this, you can see the sixth joint is moving like this. So yeah, this is how 6 degrees of freedom robot might look like in this software. Basically, this simulation represents the line diagram of the robot, and as per the DH parameter, it creates the line diagrams, and then as per my requirement, I can set the angles and it will display in this simulation. And when I click on send to microcontroller, it will send all the angles to it. Even in inverse kinematics, when I give it an angle and say compute Fik, this will compute it, give me all the angles possible. Yeah. So let me quickly show you. Oh, some error happened. Anyways, I'll look into this. Let me quickly show you the code I wrote behind this. Some exception error was there. Okay, exception happened. I guess there are some exceptions that I have not accounted for. Anyways, let me show you the software. This entire software I have written in Python using custom tkinter library for the front end. Well, this is the main.python file which initializes and creates all the tabs. Then I have serial interface tab which creates the connection between computer and microcontroller using serial or Wi-Fi communication. As you can see, Wi-Fi communication block is here. Then we have robot parameters tab. This thing this file actually has the front end design of the tab, and it has the functionality that takes in the data, saves it. Actually, I have added this one more feature. What I planned was that each tab will take in data or modify data, and all those data will be stored in a separate file, so that all those data, all those variables will be stored in a separate file, which is this file, utilities.global or utilities globals. So this file contains all the variables that I need. Like, as you remember that in robot parameter tab, I had the minimum and maximum angle. So here I have given just initializing value, home angle values, and here you can see I have created a DH table, placeholder DH table like a variable, And then from robot parameters tab, when I click on save parameter, wait, where is it? Create 6 rows, DH button panel, DH table, home angle, save function. Yeah. So whenever I clicked on save parameters or save button, all those values are going into global variables. All those values are being saved into utils.globals. Actually, this file is, as you can see here, we have, yeah, import utils.globals as G. So using G dot, let's say degrees of freedom. Yeah. So using things like G dot DH table, I can access the variables that I've created in this file and save values to it or access values from it. Similarly, all those values that has been saved here is accessed by forward kinematics tab and as well as inverse kinematics tab. As you can see, it yeah, utils.globals at G. One more thing that you remember that there was a console log on the bottom. So there is one file that takes in the message, checks the parameter like if it is information or success or warning or error, and then gives the color coding to its text and displays the message. Then I have this calculations.py. This file takes in data from forward and inverse kinematics, performs the different calculations. For example, as you can see in the screen right now, that inverse kinematics 3 degrees of freedom. This is how, if the 3 if the degrees of freedom is set to 3, this is how it will calculate the two solutions, that elbow up and elbow down solutions, and display and then send it again back to the screen. This is the cento controller.py. This takes in data from the forward and inverse kinematics tab and then sends it to microcontroller. And then I have this motion sequence tab. As I said that both forward and inverse kinematics tab both share the same motion sequencer. So this one is responsible for the motion sequencing simulation in both the tabs. So yeah, this was my demonstration of the software that I made. I hope you enjoyed this video. If you have any kind of feedback or advice regarding this software, please feel free to share it with me. I would like to upgrade this software even more. Actually, this is still a work in progress. Uh, uh, as I as I still get new ideas about this software, I keep on implementing it. And right now this software is at a stage that it's sort of complete. It does some actual work right now. It can actually control a robotic arm, which I have tried and tested with my own 3 degrees of freedom robotic arm. And now I think it's time that I upload this into GitHub. So this will be my first code in GitHub. So I guess, so yeah, this was all from me about this software. I hope you enjoyed it. Please feel free to give me suggestions and advices about this software. Thank you.